My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 243. Please turn to it. Page number 243, and today is our lesson number 345. That problem that you see there on page number 243 is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single math problem from this book. If you're interested in watching the original solution, you will find it on day number 135. Let's take a look at it. Let's see what we have here. We are dealing with the parabola. As it says on the blackboard, we're going to make him fat. So here's our original equation of the parabola, a standard parabola sitting at the origin, which looks something like this. Y is equal to x squared. Let's call that f of x. There is nothing unusual. There is nothing new about it. It's a standard parabola, as we said, and we have done this many a times. So here we have 1, 2, 3, 4, 1, 2, 1, 2. So here, when x is equal to 0, y is going to be 0. And when x is equal to positive 1 or negative 1, y is going to be 1. Because the square of positive 1 or negative 1 is just 1. Here is your x squared, which is y. When x is positive 2 or negative 2, y is 4. When it's positive 2 or negative 2, y is 4. So when it is 1, y is 1. When x is 2, y is 4. As we said, there is our standard parabola. There is nothing new about it. There is nothing novel about it. Let's draw it, shall we? What we're going to find is that, so that's it, we're done with this part. What we're going to find is that if we were to take our original parabola here, y is equal to x squared, and multiply it by some number c constant, and if this thing turns out to be something that is between 0 and 1, if it's a fraction, if we multiply it by some fraction between 0 and 1, not a negative number, something less than 1, between 0 and 1, if we do that, what we'll find is that the parabola will get fat, which is what it's talking about in the book. If you read carefully, it tells you that if c is between 0 and 1, the parabola tends to become fatter, and we'll see that in a second. So here's our new function. That's exactly what we're going to do here. We're going to multiply it by some fraction between 0 and 1. Let's multiply it by 1/4. Let's multiply it by 1/4. And let's call this new function g of x. And we're going to plot that now. So g of x is here. Here's our x and here's our y. Again, when x is 0, y is 0. There's nothing surprising there. What happens when x is 1 or negative 1? Now we have, again, we're going to have the square of 1, and then we have to take a quarter of it. So here we have, what we're going to have is x squared over 4. You see, this thing boils down to x squared over 4. And if x is 1, then we get 1/4. So when x is equal to positive 1 or negative 1, y is going to be, it's getting too crowded here, y is going to be 1/4. So it's going to be somewhere here. When x is equal to 2, what we're going to have here is 2 squared, which is our x squared, over 4. Because this thing is simply x squared over 4 our y now is 1/4 times x squared, which is our g of x, and 1/4 x squared of course is same as x squared over 4. So we take this quantity and we divide by 4. 2 squared is 4, 4 divided by 4 is 1. And now when x is equal to 2, negative 2 or positive 2, y is simply 1. Y is simply 1. And we can clearly see there our parabola has gotten considerably fatter. This is our new parabola right here. Let's put it in a different color so we can see it. This new parabola that we see there, as you can see, is our fat parabola, and the equation of this parabola is y is equal to 1/4 of x squared. Y is equal to 1/4 of x squared. And this new function, we called it the g of x. Our original function was simply y is equal to x squared, which is right here. Y is equal to x squared, and we call that f of x. That's g of x. Now what we're going to do is, watch what happens. Now what we're going to do is, we're going to stick a negative in front of it. So instead of being, I need my hands free here. Instead of y being equal to 1/4 x squared, let's make y equal to negative 1/4 x squared, and see what happens. Let's give this new function a name. Let's call it g of x. Not g of x, h of x. And that will simply going to be negative x squared over 4. What do you suppose will happen? What do you suppose will happen? Let's find out, shall we? So in this function, x squared over 4, negative of x squared over 4, again when x is 0, it's just 0 squared over 4 is just 0, the whole thing is going to be 0, it's going to start out here. When x is positive 1 or negative 1, now what we'll have here is not 1/4, but negative 1/4. All this does is that, this is the same parabola, this red one, all it does is that all the values of the y's become negative because it has negative in front of it, that's all. So this becomes negative 1. This becomes negative 1 because it has a negative in front of it. Exact same parabola, but it's going to be upside down. We just flipped it. So when x is 0, y is 0. When x is 1, y is a negative 1/4. And when x is negative 1, so we start again. When x is negative 1 or positive 1, y is negative 1/4. Y is equal to negative 1/4 when x is positive 1 or negative 1. Similarly, when x is equal to 2, before y would have been 2 squared over 4, 2 squared over 4. When x is 2, it would have been 2 squared over 4, 2 squared is 4, 4 over 4 is 1. Now it's the same exact value with a negative in front of it, so it becomes negative 1. So when x is 2, y is negative 1. And when x is negative 2, y is negative 1. Right there. The same exact parabola has been turned upside down, that's all. Let's put it in a different color. Let's put it in the blue color. And what's the equation of this upside down parabola? Well, it's the same as this guy, except with a negative in front of it. So this is what we're calling h of x, which is negative of g of x. It is negative of g of x, which is same as saying it is negative 1/4 x squared. Y is equal to negative 1/4 of g of x. That's all. That's what we see on the book there. So what does it do when you multiply it by a negative number? It just flips it. It makes it upside down. Whatever the shape of the parabola is, doesn't matter whether you're multiplying by 7 or 1/7 or 6 or 2 or whatever it is. It just makes it upside down when we multiply it by, when we stick a negative in front of it. That's all it is. So one more time, if the constant that we're multiplying it by happens to be between 0 and 1, let's make a note of it. Let's put it here. I'm going to erase all of this thing and write down what we just learned. Let's say we are done with all of this thing. So here is our original parabola. Y is equal to x squared. When we multiply it by a fraction, when we multiply it by a fraction, that is c is between 0 and 1, the parabola gets fat. What happens if we multiply it by something more than 1? Let's answer that question, shall we? This part is not, they do not show you the picture of this in the book, but we're going to do it here. What happens if we were to multiply it by something more than 1? Let's answer that question. Here what it says is that when we multiply it being the x squared here, when we multiply x squared by a fraction, something between 0 and 1, the parabola gets fat, as we can see that here. Why does it get fat? Because for each given value of x, y is now a fraction of the amount before. If it's half, then the value of y is half as before for each value of x. And if it's half as before, it does not rise as much. If it doesn't rise as much, it's going to get fatter. It's going to get fatter. What happens if you multiply it by something more than 1? Let's answer that question. What happens if we multiply it by something more than 1? In other words, when c is greater than 1. When c is greater than 1, what happens then? Well, let's find out. Let's put some number in there and see what happens. Let's make our c equal to 4. Instead of 1/4, let's make it 4. So let's see what happens here. When x is 0, y is going to be 0, because 0 squared is 0 times, it doesn't matter what times it is, y is going to be 0. So it starts out here. All the stories begin here. Now watch what happens. When x is equal to 1, listen carefully, when x is equal to 1, y is going to be, when x is equal to positive 1 or negative 1, y squared, it becomes 4. When x is equal to 1, y is 4. So when x is equal to 1, y is way up there. Y is way up there. As you can immediately see, our parabola gets skinnier. It gets a very skinny parabola now because we're multiplying by more than 1. Here's our new parabola. It's a very skinny parabola. Let's put that in a different color. What color should we put it in? We have blue, we have red. Let's use green. This green parabola that we just drew here, let's call that, we have f of x, g of x, h of x, let's call this k of x. And that's what it looks like. It becomes very skinny. So let's take a quick inventory of everything that we have here. Let's see if we're done with it. What happens if you multiply by something more than 1? The parabola gets skinnier. Now it doesn't have to be parabola. As we said before yesterday, the same exact thing, the same exact logic, the same exact thinking will apply when we're dealing with a piecewise function. Whether it's a parabola or a piecewise function, same exact thing. When you multiply it by something more than 1, it gets skinny. When you multiply it by a fraction between 0 and 1, it gets fatter. If you multiply it by a negative number, it just flips. That's all. So here's the quick inventory of what we have. Our original function y is equal to x squared is what we call the f of x. That's where the story began. Then what is the g of x? What do we do in the g of x? G of x is when we multiplied by a fraction, 1/4. When we multiplied by a fraction, that was our g of x. Our g of x was 1/4 of f of x. We multiplied by 1/4 right here. And then we have our h of x, which we simply flipped it by multiplying by -1. This is simply h of x is negative of g of x. It is simply -1 times g of x. You see, since we're multiplying by it, whatever the shape of g of x was, whatever the g of x was, we just flip it. It becomes upside down, the blue one here. And finally, we found out that instead of multiplying by a fraction, 1/4, if you multiply it by 4, it gets skinny. So this guy is the skinny guy. This guy is the fat guy. And this guy is the upside down. And that's all. That's all there is. And these are the basic things that we need to understand for the exam. They don't ask you anything complicated, they don't make it too messy, but these are fundamental things, fundamental concept, basic concept that they do expect us to know in the exam. And if you have to stop and think about it, that is not a good sign. You have to know them, you have to understand them intuitively. Don't try to memorize this thing. What I put down here, don't memorize them, understand them and plot them out. It only takes a few seconds to plot them out, and you will see that if you plot them out every single time, you pause to think about it while you're doing your exercises. While you're doing your exercises, what you will find is that if every time you stop and plot them, eventually you will begin to understand them, eventually you will begin to get a feel for them, and you won't have to memorize it. Because if you try to memorize these things, you're going to muck it up at the end. Do you understand? Muck it up with an M, not an F. I'll see you tomorrow, okay? Tomorrow we'll begin the algebra exercises that you see there on the same page, page 243. Alright? Bye now.